Okay, so this is a fast little walkthrough about using Pintos, building, and doing GDB. I'll use the first project as an example. So if you've set up your Pintos environment correctly, you should be able to go into the source directory and the threads directory, which is the directory for the first project, and build it using make. It should build without any obvious errors. Everything got built into this build directory. So we don't see any .os or anything out here. So if we want to run the the Pintos kernel, it only really runs when an argument is specified telling it what function to run. And for now, I guess the easiest way to make it run is to run the tests, because the tests are threads that the kernel would run that perform test functionality. So you can do that if you go into the build directory, and you can run the tests by running make check. This will run all the tests one by one by one. Now, when you're doing development, it's not always handy to run all the tests over and over and over again all the time. So what's actually useful is to see what test fails, and then pick one of the tests that logically you think should be passing based on the logic that you put in. You're like, oh, this test really should pass, and then focus in on that by running that test individually and debugging it. So you can see here, this is just the straight up what Pintos looks like when we're first running it. So the alarm single, alarm multiple, simultaneous, 0, and negative all pass because they're all just still busy waiting, so they pass. Whereas the alarm priority fails, and it won't pass until we put in priority logic. All of this priority stuff fails because we haven't implemented it yet. So if you wanted to run something individually, you could just scroll up and look for that test output and see where it's run. To say, here is a test that's being run. This is the command that it's doing when it runs the test. Okay, so it's running Pintos with these commands under the box emulator. It's taking its standard in from dev null. It's writing its standard error to test threads priority convar dot errors, and it's redirecting its standard output to this. So if we wanted to run a test individually, we could just run this command. The very next thing it does is it compares using this Perl script to check the results, and that Perl script is what is outputting the breakdown that says, this is what I expected to see, and this is how yours is different. So it's missing this line, it's missing this line, it has this line instead. So we can see things are just out of order from what it expects, right? It expected to see the thread of priority 27 being run between the threads of priority 28 and 26, right? But instead it sees something of priority 26 being scheduled ahead of the thing of schedule 27. So another thing I could look at is to look at the C files themselves, right? I'm in the build directory, so this is the source this is the threads directory, then the source directory. This is the tests directory. In the test directory, there's a threads directory. So this, I think we were just looking, oh man, I forget, convar, I think. So this is priority convar. So if we wanted to look at priority convar and see what it does, it says this tests that the conn signal wakes up the highest priority thread waiting in conned wait. That might not be the best thing to start with. We might want to start with something else, like maybe semaphore or something, right? That the things of higher priority for the semaphores are being woken up first. You could just pick what you feel based on the description of their tests is the right test for you to be focusing in on any particular time, and then go back to figure out the command to run it. So this was the command to run the priority convar. I'm sure it's something similar to run the priority sema. I'll just assume it's sema, and let's see. So this is going to run the Pintos script, which will load your Pintos kernel into the box emulator. It will run it with a 60-second timeout, and when it's done running this function that you specified, it will quit. So there you go. That is how to run an individual test. Right? I can see the output. I didn't do any redirection, so my error and my output are all mixed in at the same time. This is all the output that's coming from the tests. Well, I don't know. And then some things from the emulator. So let's say that we wanted to use a tool like GDB. The emulator box has its own debugger built in that works with GDB. As a result, you have to attach to it like it was a remote device. So it gets a little funky. So I'm going to log in. And you need to run it a special way. So let me just make my window the right size to see things. Somehow my window got a little bigger. Okay, so if you want to bring up this under debugging, you need to use the Pintos GDB flag. Okay? And this will tell the emulator to expose sort of a GDB server-like interface. And this is going to be a little limited because we're going to have to attach GDB to it remotely. I'm going to just make this a little smaller and bring up my other window side by side. Okay, so in the window where I'm running Pintos with the GDB option enabled, it's running the emulator. Maybe I'll overlap it a little. So it's running the emulator, and it says waiting for GDB connection on localhost 1234. Now GDB has released a lovely script, just like Pintos is a script. I think it's called Pintos GDB, that will start GDB up for you and read in a whole bunch of GDB macros that will make connecting to this easier. But you need to specify the kernel object file that it will read the symbols out of so it can show you stuff. So we're basically saying locally point GDB at the .o and read in all these macros. One of those macros that it's read in is called debug Pintos. So if you do the debug Pintos command that the macro is read in, it will connect to localhost 1234 and start attaching so that you can debug stuff. So at this point, it's read all the symbols for kernel.o. It's attached to the running process, and I could do, I could set a breakpoint. I would need to know something that I wanted to debug, so I guess it would be helpful to have another window open so I could look at the code. So I forget which test I was running. Priority sema. So one of the functions is called test priority sema. Why don't we set a breakpoint there? And then I can run it, except the run command doesn't work when I'm attached remotely. So it'll say the remote target doesn't support run. This is because we're officially connecting this as a remote thing. It's already started. It's kind of already running. It just immediately set a breakpoint. So to allow it to continue on, so I could say, where are we? Okay, it doesn't really know, I guess. If I continue, now I've hit my breakpoint, and now Backtrace will show me some interesting frames. And I could list to look at what's around me. Next will let me go through these asserts. So I could do S to step into, right here I'm in frame that is associated with the test priority sema, which I got to when run test called that test function, which run task did the run test function all the way up to main. So here I am in the middle of one of my tests, and I could take a look around, and I could print the value of sema. And here we see that it currently has 0, and its waiters don't look like they've been initialized yet. This is going to set ourselves to prime in, theoretically. I could step into it to see what it does. I could print some of these values to see what is new priority as a value. I think that I could even do things like this. To see that it has been set properly. And then I could do next. So to see right now I am inside. I stepped inside. If I do next, I'm going to hit the void return, and now I returned back to the caller. So my stack should no longer have this frame. Its frame 0 will be the priority sema. So we can see now the top of our stack. We're in the middle of calling priority sema, and I could just look to see where I am and sort of step through. And I could start to look at these sorts of things to say, is it doing what I expect it to do? Is it doing the right thing? Does everything look good? Okay. If you want to leave, you just do Q to quit. And that's it.